Hello guys, welcome back to Data. It's so amazing to have you here. And today I just want to show you how to leverage data to make predictions. I believe most of us have heard of how we can leverage data to make like futuristic predictions, but basically maybe we don't know how to go about that. So today I'm going to be leveraging data to make, prediction on like continuous variables. Now, just before we get started with it, there are like different predictions you can make. You can make predictions on classes and on continuous variables. Like classes, what I mean is you identify specific items like a bag, like a human, like an animal, or whatever. And then the continuous ones are like prices, values within a particular range. So today we'll be discussing how to be able to make a prediction on the price of a particular house based on certain parameters. Alright, so let's get started. Alright, so this is the Jupyter notebook that I'll be using to show you how to do this with Python. Yeah, so I've grouped the notebook into different categories and we're just going to run through and see what it entails. So first of all, I'm importing all the libraries that I'll be needing. So first of all, here I'm importing Pandas, which is to convert my dataset into a data frame. And since I'm getting the dataset from Scikit-learn datasets, I'm also importing the dataset, Boston housing dataset from Scikit-learn dataset. And then I'm getting the model selection, which helps in, to break the data into train and test. And then I'm also importing like a linear model, which is what I'll be using for my linear regression. And finally, I'm also importing the metrics that I will use to score the performance of my model. All right, so we're gonna run this, importing the basic, libraries. And then the next thing that we're gonna do, we're gonna load the library to a Pandas data frame. So this is the way we're just gonna call this because we've already imported it from Scikit-learn dataset. So we are just going to call it in here into Boston dataset, and that's what I've done. And then read it into a Pandas data frame, then taking the data and then the columns from this dataset, it contains the columns, and then so the feature names of that dataset is the column. So we're just going to put the columns right there and then just load it into a Pandas data frame and name it DF Boston. All right, and then we also set the target, which is more like our Y label for this data. Yep, so we just set our target there from the Boston dataset. All right, so I'm gonna run that. Yeah, so if you want to know more about the data, we can actually just use this link and you would get to read more about the Boston housing dataset. So so basically it contains like different variables. It has like about 14 variables, of which one is like the label, which is a target that we'll be trying to predict. So it has all of these variables that helps in predicting this target. So you can follow the link and learn more about it. It was collected by the US Census Service. Yeah, so back to our notebook. So let's check out the data set. So we just go and do a Boston.head. It's going to display the first 5 rows of the data set, and these are the different variables, and the target is what we are trying to predict here. Okay, so but these are the different variables that are in that data set. So let's look at the information on this data. So right now we can see that we have about 506 of rows, and then none of them it's empty, so they are all filled. So it's more like a complete data set. Actually, in real life scenario, you might not have this kind of data set, but just to be able to show you how to do this, so that's the reason when I'm using this data set. Yeah, so it's totally complete, and we're not going to do like exploratory data analysis on this data. We're just going to go straight into building the model, because that's what I want to show you today. I've already done a video where I explored like a data set, and you can actually look that up. Okay, so also looking at the spread of the data, the describe actually gives us the spread of the data, telling us the interquartile ranges, the mean, the count, all of that. And this is it. All right, and then the shape of the data, let's get to the number of rows and the number of columns. So like I earlier said, we have like 14 different columns, and then we have about 506 rows in this data set. Of this 14, one of the column is the target variable that we're trying to predict. So yeah, so one of them is like the y variable, while the remaining 13 are like the x variables. And the next cell immediately shows that. The next cell immediately is where we are splitting the x variables from the y variables. So the x variables are actually all the variables except the target variable, except this. So every other thing here is the x variable, and so we are loading that into x. So we are using axis 1 because axis 1 actually represents the column, and if it was axis 0, it's probably we are going to drop from the row. But since we're dropping a column, we use axis 1, and then so we are dropping the target variable, but every other variable is loaded into the x, and then here we are moving that, we are writing that target variable into y, which is what we want to predict. So let's run that. Okay, so right now let's view our x. So we can see that our x contains 13 different features except the target variable, which is what we really want to do. You can see that from here. And then our y basically contains just one, which is like one feature, which is the target. Okay, great. So one thing about when you want to build a model is you have a complete data set for this kind of supervised learning, where you have like the label and then you have like features that you want to predict. So the thing is, you have this data set, but you need to split the data into what I would call like a train and a test. So you use one part of the data set to train your model, and then you also use the other part of the data set to test your model to see how your model is performing on new data. So if it's not performing too well, you try to optimize the training again and then check the performance. That's the way we get to build a data model that is used in predicting, anything we want to predict. So you build the model and then validate it by trying it on a data set that the model has not learned of. So this is what we are doing in this next cell. We're trying to split the data into a train and a test set, and we leverage on this train test split, and then we are inputting our x and then our y, and then the train size is actually the percentage of, or a fraction of the data that we want to use for training. So we're using 0.8, meaning we want to use 80% of the data for training and 20% for testing. So we can see the data actually will split it into like the x train, the x test, the y train, and the y test. The y is your target, and then the x are like your different feature variables. So let's split the data, and if we split it now we just want to see what the shape looks like. So we can see now that the x train and the y train, this is 80% of the data, actually like 404 rows. Yeah, 404 rows, but 13 columns for the x train, and then 404 rows and just one column, yeah, for the y train. And then for the y and x test is actually 20% of the data. So we'll be using these ones to validate our model, while we'll use these ones to actually train the model. So let's build our linear regression model right now. So just as we've already imported the linear model from here, so we're just going to call the linear regression method on that model. Exactly what we are doing. So we just call the linear regression method from that model and name it model. So we are trying to instantiate the linear regression, method used with this model name model. So now this is where the actual training occurs. So you actually fit your data into your model, and then in this case you actually fit both the x variables and the y variables into your model. So the linear regression algorithm basically learns of the features of the x and how it relates to predicting the y, and then comes up with an appropriate structure, or what I would call a model, and that's how it's being developed. So here we are going to fit this data set into the model, and yeah, then the next thing we want to do, now we've trained our model, the next thing we want to do is we want to predict, right? We want to check what our model is giving us as the score. So by the way, this data set is what we are predicting is the price. The target is actually the price of a house based on these other features. So you're trying to predict, okay, so how much would this house cost if this house has these kind of features? So that's basically the goal of this linear model that we are trying to build. So Yeah, so here now we're going to predict the model, and in predicting it, you only take in the x variables because you want to predict what the y is. So in this case, this is where this is the reason why we left out 20% of the data for testing. So we are going to test using the x test to see how accurate it is in its predictions. So now we are going to test this and then save it as y pred, and I would also want to see like the printout of y pred. Wow, so these are our predictions from the model. So the model has learned and it has predicted all of this, right? So now our model has been trained and it is going ahead to make predictions, but we also need to be able to say how our model is performing. Like, yeah, you can make predictions, but how well are you performing? Because you don't just want to make predictions that are totally false or predictions that will totally lead to loads of errors. You know, in this case, we are talking about prices of house. So what if you have a house that is supposed to cost on a very normal day, you know, like $1,000 or whatever, and then your model is predicting $20. So you also need to check the performance of that model. And that's what the next thing it's for. So we want to check the performance of our model. So we're going to check like, yeah, we have like the model coefficients. Just before I'm going to explain what this is. So these are like the model coefficients, which represents, you know, the coefficient of each of the features that we used in training the model. So this should be 13 for the 13 different features we used in predicting the model. And then we also, you know, have the model intercept. All right, so I'm going to explain this now. So if for those of us that did like a little bit of math and we know things about like the straight line graph, you would remember y equals mx plus c, which is the equation of a straight line graph, where you can actually tell y given any value of x based on, you know, your slope and then the intercept. Right, so this is the exact structure that this model is actually using to make predictions. So your y is your y, and then, you know, your m are like the coefficient of each of your features, while your c is the intercept. So if you have like x, if you input x to this formula, it's going to predict y, and that's what your model is using here. So basically what it's being done here is that our target, which is yeah, I'm trying to get, yeah, so this is our target, right? Okay, I'm just gonna run this. I'm just gonna, so that I don't have to go up all the way. So I'm just gonna run this here. All right, so our target here, which is like y in this case, it's equals to mx, which means it's gonna be like this value, because this stands for the cream, so it's gonna be minus 1.11 times cream. Okay, let me just close the spaces. Then plus 4.41 times Zn plus 3.28 times this, and then plus all of that, right, for all the x, then plus your intercept, which in this case is 35.86. So basically you can see this formula is being played out here right now. So that's how we are making these predictions that we made, because the model has learned and has come up with these coefficients for each of these features, and then it has also gotten the intercept, and so with that it can adequately predict any, you know, price of any house based on those features. So basically this is what it means. It's just using this, and then it just keeps going. So in a nutshell, this is how the linear regression model actually works, and that's how the prediction works. But then we also need to check our performance. So one of the ways we check, we actually use like the mean squared error. Now the mean squared error basically uses the difference between what you predicted and what the exact figure is, and then it just sums it up and then squares it, and then just calculates the error. So that's basically how it calculates the error, just the difference between what you predicted and then what it is supposed to be. So like we can see from this formula, this is the formula for calculating the mean square error. So this is our original value, what it is supposed to be. This is our y test minus this is our y predict, and then we get the square of that and then divide it by the total number of data set that we have. Yeah. So let's check our mean squared error. Now the goal is you want to minimize this error as much as possible. You want to minimize this error because you want your model to perform better. So in order for your model to perform better, you also need to minimize the error as much as possible. So you always want to have a very little error so that your performance can actually be good. So while you're reducing the error, you're actually increasing the performance. So the next thing we want to see is the coefficient of determination. This basically tells us how good our model it's performing, because it literally uses the mean squared error of the model that we predicted divided by the baseline mean squared error, which is basically the the mean of all the of all the features in the data, and it just does this division, and it cannot be more than 1 because it's definitely 1 minus it. So the R2 score actually tells us how well our model is performing. So in the percentage sense, I would say this is our model is performing at a 75% accuracy, meaning it has predicted about 75% of the y test values correctly, and it has missed out about 25% of that, which is not pretty much too bad for the first model we are writing, but basically that's what it is. So to actually wrap this up, I want to go around what I've done. So literally I just read in the data set from Scikit-learn dataset, and I loaded it into a Pandas data frame. I looked through the data set just to have like an overall information in it, and then there's a link here for you to read more about the data itself, get to know what each feature is, and because all of this represents something, so you get to read all of that. And then so after checking out the data set, I basically just looked at the shape and then splitted my data into the the y and the x, because I need to differentiate that. And then so we got the x, and then we also got the y. And then you try to split your data, because you must always have a data set to validate the performance of your model, because if you cannot validate the performance of your model, then you cannot tell how good your model is performing, which does not make sense. So so we split the data, and we used 80% to represent that of the train and 20 for test. So we split the data, and then we checked out the shape of it, and then we instantiated our linear model. And in this case, we are using linear regression model for because we're predicting continuous variables. And then we trained the data by fitting it into the model using the X train and the Y train, and then we did our predictions. So these are our predictions. Then the next thing we did was to check the performance of the prediction against what the actual value is, which is Y tests. So we're checking our Y predict pred against Y tests, this, just to check the performance. So then we got our coefficients for each of the features, and then the model intercept, and then we looked out for the error, the mean squared error, which will tell us how our model is performing. So the lower the error, the better our performance, but the higher the error, the lower our performance. So kind of, if this is lower, this is higher, and if this is lower, definitely the error is higher. So the goal is to minimize this error and increase the score. All right, so that is how you can actually leverage on data to make predictions. into the future of whatever you want to. Okay, so thank you so much for spending time watching this video. I believe it's been knowledgeable for you, and the mystery of how to, be able to detect prices or you leverage data to make predictions has been dissolved now, and you know how to go about it. Though it gets complex based on the kind of predictions you want to make, but this is the very basic part of it. So you have an idea on how data can be leveraged to make predictions, and that's quite great. And if you really did enjoy the video, how about you click the like button and then share with your friends. And if you still haven't subscribed yet, you don't want to be missing out on this kind of content. So please do click the subscribe button and also tap on the notification bell so that once I drop a new video, you will just get it instantly. All right, thank you so much, and I look forward to seeing you in my next video.